So good morning, everybody. This is Eric Hubert, the Personal Safety Market Segment Manager for Levitt-Safety. For those of you who don't know, Levitt-Safety is a safety company that's been in business for about 80 years, and we've dedicated ourselves just to the safety industry. And we're happy to be partnering with Ansell on this webinar. Hosting today the presentation is Chancellor Wyatt, who's the Associate Director and the Chemical Electrical segment manager for Ansell. So very specialized. He's had 17 years in the industry and is going to be talking to us about everything you need to know about selecting the right chemical glove. I'm going to pass it over to Chancellor and let him start up on his presentation. If you have questions that come up during the webinar, just type them into either the chat or the question box, and we'll answer everything at the end of the webinar. So Chancellor, whenever you're ready.
Thank you, Eric. So today during the webinar, we're going to be focusing on how to properly select the right chemical glove, as well as some of the best practices around the usage of chemical gloves. We're going to cover 4 questions throughout this webinar, one being why chemical gloves, another what are the factors that influence chemical gloves, and then how to properly select chemical gloves. And then from that standpoint, once you have your selection completed, once you use your gloves, what's the proper way to dispose of chemical gloves, which is something that's typically not always considered in the overall selection process. So let's start by understanding why chemical gloves. So everybody's exposed to chemicals every day in their daily jobs. You'll notice that within numerous industries, 89% workers are exposed to oils and greases. And that's just oils and greases. There are other harsher chemicals out there as well that workers are exposed to, and over 60% encounter those chemicals. And that's due to wearing the wrong PPE or wearing the wrong hand protection, where it may not necessarily be a chemical glove, but it may be a mechanical glove, a disposable glove underneath, which doesn't necessarily give you the protection that you need over a certain period of time. And so when you don't have the proper hand protection, that can lead to various types of injuries such as dermatitis. You can have burns, even long-lasting effects when it comes to cancer that can ultimately lead to death. And so this is a very serious category and needs to be given special attention when it comes to the proper selection to make sure you're able to do your job and do it without any risk to yourself. So when you talk about chemical gloves, what's that really mean? How do I know a product is actually considered a chemical resistant product? And there's different regulatory requirements that actually help drive that. And there's various standards that exist today. One being EN 374, which is something that's commonly used throughout the industry, but as well as when you look at North America, you have ASTM. Those standards are going to be in parallel. They provide the same similar types of results in terms of driving the direction as to whether or not a product is considered chemical resistant. But when it comes to the various markings that you see on gloves today that are considered chemical rated, you're going to find those markings are driven by the EN 374, which is a European standard. But there is harmony between both standards, that do exist. So you're not going to get different results if you follow ASTM versus following EN. But those are the governing bodies that allow you to really define whether or not you have hand protection that is chemical resistant. So understanding that, what are those factors that we need to make sure we consider to say if a product is chemical resistant? So the first factor is penetration. And penetration is pretty much just the idea of a chemical or microorganism being able to penetrate or go through a glove material. And so the idea behind it is you want to recognize whether or not this glove is liquid proof. And liquid proof could be across all different liquids, but you want to make sure there's no pinholes or anything that's in the actual glove that can make it defective and allow the chemical to pass through and potentially come in contact with your hand or your forearm, depending on where the glove is actually in contact with the chemical, to cause that lasting effect that we mentioned previously. And so penetration is done with very different types of test methods, but at the end of the day, it comes down to is if you look at a sample, from your production run, you want to make sure that you do not have a batch that's considered defective. There's different types of techniques they use to actually look at what's that inspection level to ensure that you are defining what something's considered penetration. And when you have gloves that are considered, unable to be penetrated and actually meet the stringent requirements when it comes to acceptable quality levels, you're able to actually be able to say that glove is ideal for microorganisms or different pathogens, bacteria that can be used in different types of outbreaks such as Ebola and so forth. And the glove gives you even greater protection beyond just your standard chemical. But right now, penetration from the context of this presentation really comes down to whether or not the glove is liquid proof. So what are those methods that are used? You have a water leak test as well as an air leak test. Both methods will provide the same results, but at the end of the day, what you're looking for is whether or not you have a leak. Does the water come out or does the air penetrate and come out? If that happens, then you know that the glove is not considered liquid proof from the operations. Thus, you cannot necessarily call that glove chemical resistant. And that's just one of the criteria that allows you to recognize whether or not the glove is truly chemical resistant. So another factor to consider is permeation. And permeation is something that we all use every day when it comes to understanding what we call breakthrough times. And what you'll find is that each standard that I mentioned, ASTM as well as EN, both factor how you do permeation and calculate permeation. A little slight difference between the two in terms of when you actually recognize when a chemical permeates that material, but you'll find that your answers are going to be typically around the same due to the fact that you have ranges at which are considered acceptable when it comes to permeation. And I will explain that shortly, but for the most part, what you'll find is that when this test is done, it's always done at room temperature, a normal condition. And that's important to note as we talk later on in the presentation about selection process. It's important to understand that factor. So when you're doing a permeation test, there are 16 chemicals that are chosen. And what you're doing is you're not necessarily testing against all the chemicals, but you are required to test against a certain number of chemicals in order to achieve a certain rating that's required from the EN standpoint. And the rating is going to be based on having that pictogram, which I'll show you the next slide, on your glove that gives you a quick indication that the glove is chemical resistant. But these chemicals are considered the common chemicals that you will see within the industry, regardless of it's automotive, manufacturing, transportation, aerospace, whatever the case may be. These are typically the common chemicals that are chosen. Thus why these are the ones that are used. But there are more, and we recognize that. However, based on the standards, these are the ones we have to pick from in order to define whether or not your glove is chemical resistant. So when you look at going through the testing for permeation, you actually establish what we call breakthrough times. And this is something I'm sure everyone on this call today, recognizes in terms of the color coding, which is almost like a traffic light, where you recognize whether or not, you have a glove that's going to be compatible to that given chemical hazard, whether or not it's not going to be compatible. And so this is something that's common that you'll see where you have various performance levels that go from 0 to 6, 6 being the best, 0 being the least. However, 0 does not mean the glove is not good enough. It just means that you can't use it for a long period of time. It's typically more around the idea of not recommended or splash, depending on what you're doing. And you have different types of gloves that would actually fall within that category. But at the end of the day, it's important to understand exactly, where you fall in order to get the proper permeation, and then understand exactly the proper usage for that glove. Now, if you do pass this test and you do go through the requirements meeting this permeation for one of those given chemicals I mentioned, you're going to be able to have a certain type of pictogram actually on your glove. And as I mentioned previously, this is the easiest way to know if that glove is chemical resistant. And based on the current standards for EN ISO 374, you're going to have a type C, a type B, or a type A. And type C just means that you were able to pick one of those chemicals on that list and you were able to achieve more than 10 minutes without any permeation. And then type B, you were able to pick at least 3 chemicals on the list of 16, and you're able to achieve greater than 30 minutes without permeation. And then type A, you're able to pick at least 6 chemicals which gives you greater than 30 minutes without permeation. Now, it does not mean if you have a type C versus a type A that a type C glove is not good compared to a type A. All it does is just gives you indication that this glove could be used in different scenarios based on those chemicals that we listed. You will always need to go out and check using different tools whether or not that glove is going to work, because a glove that might be type C still could probably work well against a chemical that happens to not be tested, for that glove in order to get that type of marking. But do not use this as a way to measure if you have a glove that's better than another glove. I do not want that to be the right direction to take. But what it does, it just gives you understanding that this glove offers some level of chemical resistance. And that's what the key takeaway is when you see this pictogram on your actual glove. Now, that being said, another key factor is degradation. And this is a factor that's not always spoken to. Many times people ignore this factor. However, it's really quite important, because typically what it means is that if you have a chemical that comes in contact with that glove material, and that glove material immediately changes, and the change can be physically changed that you can see in terms of the glove stretching, or actually, deforms. It has a different type of look in terms of if it's not green, it's going to be faded and so forth. That's a quick sign that that glove is not appropriate for that chemical, regardless of your permeation. And so it's very important that we understand degradation. There's different types of test methods to go after and try to define degradation. And this data has to be accessible by the manufacturer. And so, if you ask, Levitt, how to get this data, they'll be able to contact us at Ansell. We'll provide you this information without any problems. But this is something you should always take into account, because even though you may have permeation that shows the glove is okay, it doesn't mean that it's going to be compatible from a degradation standpoint, where the glove truly will change and not be of any value in terms of offering chemical resistance. So it's important to at least just note the idea of degradation that exists as well when you look at the other factors. So understanding those factors, penetration, permeation, and degradation, and that's really gives you the foundation to really define whether or not you have a glove that's considered chemical resistant. So now, once you know that you have a glove that's chemical resistant, the key is, well, how do I know what to choose, when to choose, and how to select the proper glove? So let's talk about that and understand those different steps that you should go through. So the first step is to identify the primary hazard. So what is the chemical that you're going to actually be encountering? Is it going to be a chemical you're going to be dealing with for a long period of time or short period of time? Is there a particulate that you have to deal with? Is it a biological agent? If it's a microorganism, a bacteria, is it agent, or is it even a virus? Where it's not necessarily just a chemical, but maybe it's for a cleanup application where you're dealing with more of a virus. That's just as important as well, because that's something that's also will be noted on the glove as well. So first you need to understand the primary hazard that you're going to be encountering. Then from that standpoint, you look at understanding the level of exposure and the time of exposure. So a level of exposure will come down to whether or not you have splash or immersion. If you have immersion, which is typically the testing that you will find when it comes to permeation and so forth, that's going to require a different type of way of looking at the product choice versus splash. Where typically splash, you would use disposable gloves that you could throw away. Where immersion, you want to use gloves that are considered reusable, meaning you could clean those gloves and actually reuse them in another time in the near future. So, understanding the level of exposure is important in part of your selection process. And then your time of exposure. And this is important based on the fact that if you have a glove that you're going to only be using for 5 minutes, for example, or for 20 minutes, even though your permeation data shows that the glove is good for 480 minutes, it's important to understand exactly the amount of time, because you don't want to wear a glove that's going to only last for a short period of time, even though it may work for that time you're actually doing that particular job. But what you don't want to do is get into a situation where you forget that that glove is going to start permeating after that certain period of time has elapsed. And then you have the glove on for your entire shift, which in turn gives you exposure hazard or exposure risk to that chemical. So you will be very mindful exactly what the time of exposure is, because then you'll know how to make the proper selection, in terms of ensuring that you have the right glove for that period of time that you really need the glove versus just picking any glove that will show up on the chart. So something to be very mindful is level of exposure and the time of exposure. And then another area also is the use conditions. As I stated previously, permeation is actually driven based on working at what we consider room temperature. And many times you're not working at room temperature. You're working in a very hot plant where there's a high humidity factor. And when you deal with high humidity, that's where you can start having some changes to anything that's exposed to that heat. So anything exposed, like your gloves actually on a molecular level will actually change a little bit. So it's like looking at, for example, a piece of cotton and you actually pull it and stretch it. When you pull that cotton, you actually will open up the pores. So the same idea is when you're exposed to high temperatures, you're actually going to cause the material to actually expand and stretch. So you open up the pores, thus the effectiveness isn't the same as what was originally assumed based on the data that you captured to help you understand the proper selection criteria. It doesn't mean that the glove won't work, but you got to be mindful that, you know, what you maybe determined to be considered 480 minutes of appropriate time to use a product may actually only be 120 minutes. So just something to be mindful of, you know, as you consider working in very hot temperatures, that there is a change in the amount of exposure you can have for a chemical glove. And then another thing to consider is secondary hazards. If you need, you know, cut protection, if you need a glove that doesn't have any static discharge, or even thermal, hot or cold. Those are things that sometimes get lost when you look at chemical glove selection. And so you got to make sure when you look at your gloves that yes, you will deal with that chemical risk, but at the same time, there are other risks that you have to deal with to make sure that you're able to be productive on your daily job. And then from there, you go ahead and look at all the technical data to your disposal, which will allow you to go ahead and make the proper selection and then proceed from there in your glove usage. Now, that being said, you don't have to be an expert. You don't have to have all the knowledge, you know, that was just given to you previously. There are tools out there. There are different things you can do to kind of help give you some guidance and direction. Number one, there's chemical resistance guides that you could get online, as well. You get hard copies as well that will have select gloves across various polymers, you know, against numerous chemicals which are considered popular chemicals, just to give you some direction as to the proper permeation as well as the degradation, so you have some guidance as to really what makes sense that chemical hazard. So that's a tool that is available for you to use to help you with your guidance and knowing how to pick the proper hand protection for a chemical hazard.
Great, I love you.
Then you also have online tools. One being AnsellGuardianPartner.com/chemical. This is an online tool that allows you to go in and pick various gloves to your liking, as well as you can pick various chemicals either by the cast number, or you can start typing the chemical name. And what that does is it allows you to quickly get a visual indication from a chart that will provide you permeation data as well as degradation data to recognize whether or not that glove is going to be sufficient, you know, for that particular hazard based on the amount of time that you need that product to work for you. So that's another tool you can use that's online. It's open for everybody to use right away. If you don't have access to an actual chemical glove resistance guide, you can use this as a way to help you in your selection process. But as well as speaking to Levitt-Safety, they also have a glove selection program that you can take advantage of as well. And I would recommend you reach out to them and speak to them if you need to have guidance on how to do proper selection on chemical gloves to make sure you're confident in your choice as you go forward in your job. So now we want to talk about best practices. Once you actually have a glove and you're using that glove, you know, you want to make sure that you're disposing the glove properly. And one of the things that's very important to understand, once a glove has, you know, splash, you know, from that chemical or has some kind of contact from that chemical, that's when the clock starts ticking. Meaning, at that point, the glove is going to try to start working through the material to get through the material and potentially contact your skin. So the amount of time it will take is based on what we discovered relates to permeation. But at the end of the day is once you use that glove, you got to be mindful that the chemicals could still be on the glove. So if you're not properly taking care of the glove in terms of cleaning or disposing, you're not going to be able to use that glove again without, risking yourself being in contact with that chemical hazard. But some tips to think about is, when it comes to laundering, we do not recommend you launder the glove. When you launder the glove, there's a greater chance being exposed to those detergents as well as the heat and so forth. You can actually change the properties of those gloves. So the best thing that we recommend is that you just rinse it down with like cool, cold water, and then you take a damp cloth and you just wipe it down. That's the best way to properly clean the glove if you choose to reuse it. But I would not recommend to launder the glove using your typical laundering methods that you would have for other types of hand protection products. Then also make sure when you look at using a glove, for the second time or the third time, always inspect the glove first. Make sure there's no tears, discoloration, any type of structural changes, or even signs of degradation. You don't want to just put a glove on assuming that it was the same package. I would say be very mindful that you should.
I know she did statements. I just assumed it was like we might get there and there might not be even anybody there. I drove past it.
Lastly, when it comes to disposables,
I was driving. I'm like, what other businesses are
disposable
here?
gloves you should discard immediately.
I just felt like it looked like a shed.
Splash protection only. Do not reuse those gloves. Only certain chemical gloves can be reused. Dispose of the proper way based on municipality, based on local laws. There's ways of looking at how you dispose different types of gloves out there. So please follow the local laws that you have to comply to on proper disposal of gloves. Now, when it comes to shelf life, typically, not too many people really understand this, but not all gloves are going to be used at a rapid pace. So if you have gloves that actually are going to be reused or for a long period of time and they sit around, be mindful different materials only have a certain recommended shelf life. So in front of you see where guidance are for 3 years and for the guidance of 5 years. Please be mindful different materials will only last for a certain period of time. So it's not recommended that you still in gloves forever thinking that after 6 years you can use a glove and there's no issues whatsoever. Gloves over time, as they're exposed to the elements, will change, will degrade, will change in terms of the properties, especially if exposed to sunlight. They can change their properties or exposed to different environmental conditions. So you don't want to take into account or think that the glove is going to be okay, and it's not. So make sure you be mindful of that. When you dispose the glove, again, make sure you use the proper local regulations to dispose the glove, because this is a material that's not considered recyclable. So you want to make sure that you dispose it properly based on your governing laws and so forth. So those are the best practices, things to think about after you choose your glove and you're using your glove, provide you that protection. Make sure as you look at using the glove and reusing the glove, and then disposing it in the proper manner that makes sense, such that you're going to be constantly optimized in your productivity, but at the same time protected from that chemical hazard that exists.
I don't have it on that.
So at this time, I'm going to turn it back over to Eric to speak about things that Levitt-Safety could do to further help you.
Yeah, I'll have to put it on my phone. I think it's just straight down until each line. Yeah.
Eric?
Hey, we're getting some feedback. We're looking into the reason why. We think we have a cross on one of our VoIP lines here. Give us a second. I think we're good now, if you want to continue. Oh, sorry, I'm up with the glove review. So, talking about the glove review process, if a lot of this information has scared you, it's overwhelming, just know that there's some free resources out there for you to help. One of them is the glove review, or the glove audit process, as some people call it, where you come to us looking for help, and we pass off to a company like Ansell, who is one of the best at doing it, particularly in the chemical glove sphere, where we'll come in, we'll take a look at what SKUs you're using, what your chemical hazards are, and assess what the best glove is for you to be using and make recommendations. The best part about this process is that it helps you reduce SKUs, and eliminate extra SKUs that you don't need, which helps on your spend and increasing the life cycle of your gloves, and making sure that you are having the best possible protection against the hazards that you have. We can also provide information on how to reduce waste and possibly recycle your gloves. There's a few programs out there that will actually recycle the gloves for you. We have a URL at the bottom there, which is a link to our page that talks a little bit more about glove reviews, and also where you can submit a request, or you can contact your local Levitt-Safety rep or myself if you have any questions. And help you get the gloves that you need for the tasks that you have. So this concludes our presentation on chemical gloves. If anybody has any questions, please type it into the chat box and we'll address them. First question that we have is, how often should you do a review to your chemical gloves? Chancellor, what would you recommend there?
So I recommend that once a year that you go through a review. It doesn't have to be very detailed, but typically what happens is companies introduce new chemicals all the time. And what happens is most times companies assume that the gloves that they're currently using will work for those given chemical hazards. So I would say once a year, just go in and work with Levitt-Safety to actually do an audit and just make sure that any new chemicals that are introduced are going to be acceptable for those gloves that you're wearing. If not, look at try to use different gloves, but just to make sure that you're going to be constantly safe as you work, I would recommend once a year.
Thank you, Chancellor. The next question that we have here is availability of documentation. So everybody knows, because you're registered for the webinar event, we're going to give you a link that's going to go out most likely tomorrow or the next day, which will be a link to the recording of this presentation, so you can then view that with your staff. Here's another one for you, Chancellor. How does body temperature affect permeation? Somebody working in an area with room temperature, but their hands are hot and they're sweating.
Yeah, so typically there's different types of gloves that are used out there. So you have what we consider unsupported chemical gloves as well as supported chemical gloves. And typically when you have these supported chemical gloves, that typically will be consist of like a liner that's cotton flock liner or some type of liner that's used for thermal protection and so forth. And that's usually good at actually absorbing some of that sweat and provide that sweat management, that heat. And so it allows your gloves to actually work the way they should be working in a regular normal temperature. However, if you have unlined gloves where you start feeling sweaty and so forth, typically it's not going to be an issue because it's on the inside. And where the issue when it comes to the temperature exposure is more so on the outside of the glove, where the chemical it will have the first contact. And so you're not going to find the same risk that I mentioned, understanding the working temperature to be as prevalent based on you sweating your body temperature. Because typically you're not going to go at the same level of temperatures that you'll find to your exterior.
Another question for you, Chancellor, is how useful is the information on an SDS regarding glove type?
So on an SDS, what you'll find is that the glove type they give you may say nitrile, or they may say wear a natural rubber latex glove, and that's fine and all, but the problem is there are various different types of gloves that are recommended in terms of nitriles, in terms of natural rubber latex, or even butanol and so forth. And so the part that you work with your distributor, such as Levitt-Safety, it actually utilize the tools that we recommend in the webinar to make sure you understand whether or not it's going to work, for that period of time. Because I can get a nitrile glove that's only 13 mil, and that 13 mil nitrile glove may not necessarily work that well, but if I give you another nitrile glove that's 18 mil, it'll work better. And so when you look at SDS, they just tell you a nitrile glove. Well, there's more behind what that means. And it also doesn't tell you about some of the other hazards that you may need to overcome, such as having the grip, having thermal protection, having cut protection, things like that. So I would say that gives you good guidance, but at the end of the day, reach out to your distributor, work with them to make sure you have really the right choice.
Another question here on what are your thoughts on double gloving, Chancellor?
I'm not a fan of double gloving. Typically, your hand gets bulky. You really don't have the same comfort that you need. However, if you're looking at double gloving with a mechanical glove, for example, if you need to do that because you need to look at having a certain level of cut protection and that you can't find in a chemical glove, that's fine. I would say wear the chemical glove over top on that mechanical glove, just to make sure you're getting that certain cut protection that you need. But ideally, if you want to make sure you're able to preserve that comfort to do your job without being in discomfort, you want to just kind of wear that one glove as best as possible. But if you need to have certain features and benefits that you're not getting with that chemical glove, even though that chemical glove is the right choice from that chemical hazard standpoint, such as you need cut protection or you need puncture protection and so forth, I would say that's the appropriate time to wear a mechanical glove underneath the chemical glove. But I would not recommend using a mechanical glove on top of say a disposable and so forth like that. That's not appropriate. And the reason why is because, number one, the disposable is only going to last for a short period of time. And so typically you forget the disposable is there. And so you keep working, and while you're working, that chemical is actually permeating and potentially could cause risk because it's going to contact your skin. But at the same time, when you look at disposing of that single-use or disposable glove, typically you keep the mechanical glove, and that's not appropriate either because the mechanical glove has those chemicals on it as well. And so you want to make sure that you get a glove that you feel confident there's not going to be any type of permeation or penetration for what you need during that period of time to assure you're going to be safe throughout your job.
What about part washing stations that have gloves built into the station? Will they degrade over time, and how do you replace them?
So part washing stations, those gloves typically you're washing with certain chemicals to look at trying to take off any rust and things like that. You gotta make sure you understand what that glove is and make sure you understand the chemical you're using. If you're using an acetone or something like that, if you're just using general water, it's detergents, that's one thing. But if you're actually using an acid to remove rust, look at refurbishing a part, it's very important that you understand what that glove you're using, what the material is, because you need to make sure you replace it out based on understanding the factors that we mentioned. Because that glove is exposed to that particular chemical, it's going to start permeating, and the clock starts at that time. And so at a certain point, it's not going to be in any use. So for me to give you a time, it's really hard for me to do without understanding exactly the glove you're using. But I would say it's important to actually work with your distributor or use the relevant tools that we mentioned in the webinar to actually understand exactly how that material typically holds up against that chemical, and then you'll understand exactly the time frame that is appropriate to look at changing it out to assure that you're not going to have any risk.
Another question here for you is, we're exposed with acids, bases, and solvents and currently use disposable gloves. Is there anything else better that will help us with dexterity?
Yes, there are other gloves out there. There is a chemical glove that Ansell offers. You can work with Levitt-Safety to look at gaining access, but there are gloves that we have designed, that we have innovated around to actually look at providing the chemical protection, but as well as give you better comfort that comes out to the ergonomic fit and feel, so you have better dexterity to do your job and gain the proper grip as well. And so I would say work with Levitt-Safety to look at what we consider the Alpha Tech range of gloves. There's some solutions out there I think will fit you well that will allow you to work across those various chemicals that you mentioned, but allow you to also get a better protection over a longer period of time and still maintain that sense of dexterity that gives you that nice balance between comfort and protection.
Chancellor, do you offer help with chemical clothing selection?
So yes, if you work with Levitt-Safety, I know this is a broken record, but I'll keep saying that. So Levitt-Safety actually could work with Ansell, and we have a in-house tool called Chemical Guardian. And Chemical Guardian will actually not only just does hand protection, but it also does body protection as well. And so they can work with one of our sales reps that are located in that area to actually, apply that program and do an actual assessment when it comes to body protection to ensure you have the proper compatibility when it comes to your body protection as well.
A little bit involved question here for you, Chancellor, for you to address here. If the disposable glove is worn over top the mechanical protective glove, many times they're introduced a grip hazard, as the disposable glove does not provide adequate grip. A barrier LL DPE glove is recommended to be worn as a liner, not as a top layer. Comments on that?
That is true. So, if you look at a barrier glove, that glove is probably the greatest chemical resistant glove that we manufacture. There's not too many people who offer that type of product based on laminate films. But what I will say is this: that glove is meant to be worn underneath another chemical glove. It's not really meant to be under a mechanical glove. And the reason why I say that is because the mechanical glove is going to get saturated at some point, and so it's not going to be of any value to you. So if you want to make sure you're using a glove that's not going to get any permeation, I would recommend you typically use that as an underlayer to like a Solvex or something like that, where you can get some reasonable grip out of it, but at the same time it gives you better protection in terms of the punctures and abrasion and things like that, which you don't get with the barrier glove. But that being said, if there's a certain hazard or you need that you cannot get with the chemical glove, it's okay to wear that mechanical glove on top of that barrier glove, just so you can get a certain type of risk being avoided with the mechanical glove. But be mindful that once you finish doing your job and you're going to look at taking the hand protection off, make sure that you're treating both the mechanical glove as well as the barrier glove, meaning when it comes to cleaning it, make sure you're doing the proper things. If you're going to dispose it, then so be it. But do not just wear the mechanical glove again without thinking about, did you clean that glove? Because those chemicals are actually woven within the material that can affect you long term.
Okay, I've got one last question here, and then we'll close things up. Are there chemical-resistant cut gloves?
So yes, there are. In the marketplace, there are chemical-resistant cut gloves. Right now, Ansell has one that's going to be coming out in January timeframe. So in the interim, the best thing to do is consider using a chemical glove with a mechanical liner that's considered cut resistant underneath the glove. And that's what we recommend people to do. That's what folks do today. We have numerous examples that we could share with you with other manufacturers who are actually doing that and are having great success. But we are having a chemical cut glove that's going to be coming out in January that Levitt-Safety has already been exposed to. Unfortunately, we just don't want to put it out there just yet, only because we're in the process of getting the production completed and having product in stock. But we are going to have that product coming out, and that glove will allow you to have a chemical resistant glove with an actual nice cut liner that's going to give you great cut protection, level 3 cut protection, but at the same time give you the comfort you need as well to make sure you use a glove without having any chance of a risk from chemical as well as mechanical in your job. So stay tuned.
One more question came in. Are there options for barrier DPE chemical protection plus anti-4 cut and puncture resistance available?
Within that one glove, no. The way that glove is designed, there's no way you're going to get any type of cut level. Hence why you have to wear that glove underneath something else in order to get the maximum chemical resistance. But at the same time, if you want to look at getting the cut protection that's considered, an A4 or a much higher cut, you would either have to put that with a mechanical glove. Be mindful that you have to make sure you properly treat the gloves after use. But that's the best way of doing it. It's not going to be the all-in-one glove that allows you to do, the laminate film barrier protection plus have cut. That's something that is in our pipeline to consider and work on. But right now, there's nothing that does exist in the marketplace today.
So everybody, I'd like to reiterate again that if you need help choosing your chemical gloves, please contact us. You can either visit our landing page for glove reviews. Everybody's going to get a link along to that page where you can request one if you want some help, as well as the link to view the video recording again, which we would be more than happy to have you guys share that with your employee group. But, thank you everybody for joining, and thank you Chancellor for presenting a lot of great information there, and hope to hear from everybody soon.